Good morning, afternoon, and evening to our global audience today. Welcome to Device Authority's webinar, an introduction to KeyScaler as a service. My name is Rosa Lenders, and I am pleased to introduce our speakers for today, my esteemed colleagues Rao Chirukuri and James Penny. Rao is a technology innovator, entrepreneur, and seasoned executive in Silicon Valley. He founded and led venture-backed IT infrastructure startups that delivered award-winning products over the last 2 decades in networking, security, and analytics. His latest work is in the areas of IoT security, edge computing, and fog computing. He is currently CTO at Device Authority and is responsible for our product strategy and technical strategic alliances. James is Director of Product Management at Device Authority. He has worked in security for over 12 years, architecting and deploying complex projects for organizations across many industries. He has also designed several apps which have featured on the Apple Store. We expect the webinar to last approximately 45 to 50 minutes. You will be able to submit questions via the question window in the GoToWebinar control panel throughout the session. We will try to answer as many questions as possible at the end of the webinar. A recording of the webinar will be made available tomorrow on the Device Authority website, and everyone who has registered will be emailed the link. I shall now hand over to our speakers, Rao and James.
Thanks, Rosa. Good morning and good afternoon for some of you. Thanks for joining. Before we go into the details of our topic today, KeyScaler as a service platform, I would like to touch upon the key problem areas so that we have the right context and scope of what we will be discussing today. As most of you know, IoT use cases are all about data. You can't trust the data unless you trust the device, right? It's about the trust, and because of the scale we are dealing with is automation. So those the two are key things that we need for IoT security, right? If the device and data it collects can't be trusted, there's no point taking all the trouble of collecting it, analyzing it, worst of all, making decisions and sending the wrong controls. So just imagine a doctor or clinician sending a wrong dose of medication to a connected medical device. I mean, it's a safety issue, right? And one thing we have to understand is here is the device trust and data trust need to be coupled for these critical use cases, right? So the traditional IT security methods of applying trust using multi-factor authentication and others don't work for IoT because of the unique characteristics and the scale. The IoT IAM, let me touch upon this one. It's an emerging as an important capability to help that trust and automation for IoT security. It's not very well understood by a lot of people, but the industry experts, analysts have been providing a lot of guidance on this functionality. Clearly, the IoT IAM is not to be confused with the traditional IAM. Substantially different from traditional IAM, and traditional IAM is not really suitable for IoT actually, because you're dealing with the devices, not the human identity here. At Device Authority, we delivered the first device-centric IoT IAM platform to deliver this trust and automation. We've been offering this as on-prem solution for a while, and now we launched the same as a SaaS model a few weeks ago. This is the first IoT IAM, IoT security platform in the cloud, and James is going to provide a lot of details about it in our webinar today. But let me, take a moment here. I talked about IoT IAM. How does it fit in an actual IoT solution scenario? Here is a typical high-level architecture for IoT solution, and on the left side, you can see the IoT edge devices and gateways connecting to the IoT applications, platforms on the right side. And in a typical real-time analytics scenario, the IoT edge and the analytics could be at the same place. But in general, we have this cloud data center side analytics engines collecting the data from the devices, delivering all the value that we are talking about, right? When it comes to actually trust and automation, the things we have seen from the previous slide, the plethora of IoT platforms on the right side, they all talk about how easy it is to connect devices, secure the devices and data, I mean, at the end of the day, they all ask you to implement security with a lot of human touch. They will provide you all the hooks, but at the end of the day, it's a shared responsibility for customers, right? Take an example of AWS IoT. They ask you to put a certificate at the device, the distinct root, so that device can be connected to the right IoT core, right? So take Azure IoT Hub, a SaaS token on the device that connects and authenticates to the IoT Hub, right? So anyway, you have these different types of flavors with IoT platforms when it comes to device trust side authentication, and often the data security is not very well understood, because if you have to deliver the data from all the way from the edge to the right entity, it could be application user, that trust is very important. So we're going to talk about that IoT edge trust especially, and then extending that trust all the way to the cloud is a very, very critical thing. And that in turn calls for a lot of automation. We're going to talk about more about these open platforms, not just a closed platform where a device, known device is connected to known service that is completely owned by that entity, right? So there are technologies like PKI can play a big role, because the trust infrastructure, HSMs from PKI vendors, but really how do you connect that kind of technologies to deliver the trust, right? So let me take one more step further with a good real world use case, right? On this slide here, you can see there is a medical devices use case. I mean, the architecture, what I'm showing here, is not just limited to medical devices. It's kind of common for any type of IoT use case, industrial IoT. But I picked up the medical device use case here because, as you know, maintaining security and privacy of patient data is paramount to these healthcare use cases, right? I thought it's a good example. The first challenge here is to have a strong mutual trust and authentication between the device and IoT platforms, or servers, or applications, the users, right? The second challenge here is sensitive information flows all the way from device to the IoT platform, ultimately to the application. Now you can see that a wrong dosage of a medication going to a patient could have a big impact, negative impact, right? So the role of IoT IAM is about that key functionalities. In this case, we have shown the KeyScaler as IoT IAM functionality, and connecting to the IoT platforms, delivering root of trust. I mean, device authentication using the core root of trust from the other HSMs. But the functionality, what I'm showing here is medical devices connect to KeyScaler for registration and right authentication provisioning, and also get the crypto keys on the device to encrypt the data. And that encrypted data has to go to all the way to the applications or the users on the right side in the lab. And that data has to reside even at rest from a security point of privacy point of view, in secure mode, encrypted mode. Only authorized people or entities should be able to decrypt it, right? So that's the kind of the trust I'm showing this use case. When James talks more about the KeyScaler platform, actually you can see the different functionality coming in to bring in the trust and automation, right? So without further ado, and let's go into the code details. I will hand over this to James now, who will provide you all the details we need for this webinar today.
Yeah, thank you, Ro. So what we're showing here, so this is really a architecture overview, for lack of a better term, of the KeyScaler system that we traditionally deploy on premise. We actually didn't stray from our typical on-premise deployment model for KeyScaler as a service. We took the existing parts that we have and made sure to deploy the system in a redundant architecture and across multiple availability zones to eliminate any kind of single points of failure. But I think for the core of it, what's important here is that this is traditionally what we would deploy on premise for our customers. So just to kind of go through a few of these, you'll notice that the system is actually split out into several services, which each kind of represent an important role in the platform. And truth be told, some of these are split up into even further microservices that actually underpin them to help us achieve the scale that we need. And that's important to remember, because it's gonna really helps us scale the service as the user base grows. We can make sure that any particular part of that service that kind of starts to kind of reach peak capacity can be scaled out as just a single component instead of splitting out the whole system again. So some of the services that we have, so starting with the control panel at the top right of the diagram, this is the administrative user interface, and it's where you can go to create the policies, manage devices, create registration control records, and view the security event logs. The usual stuff you'd expect from an admin panel. That control panel actually connects into the APIs that are exposed by the Device Authority Engine, or the DAE. So for partners that are offering KeyScaler as a service to their customers, they can leverage the same APIs to offer KeyScaler functionality to their customers through their existing customer portal, and create a kind of single pane of glass user experience. So the light blue box in the middle is the DAE. It represents the brain of the system. It's responsible for generating authentication challenges, validating responses from devices, detecting device clones, enforcing policies, and really managing things like the whole certificate provisioning process. Wrapped around that DAE is what we call the service access controller. And that really acts as the interface to the remote IoT devices. So what we're talking about here is the very nature of IoT means that devices are, often outside of your traditional secure perimeter. They're in, quote unquote hostile environments, and can't always be trusted, from the get-go. So it's for this reason that the device communication actually only happens with that service access controller, and not with the core security service, the DAE. So it acts as a gateway or a broker or bouncer, I guess, that passes messages between the connecting device and that DAE brain to help prevent any direct exposure to malicious devices. At the bottom of the diagram, you can see the service connectors. So these provide integrations between KeyScaler and other existing services or platforms from our partners. One good example is the AWS IoT connector that provides connectivity between KeyScaler and that AWS IoT core service to upload device provision certificates so that devices can authenticate. And we'll talk about that in a little bit more detail in a second. And lastly, at the top left, KeyScaler supports two authentication methods. The first is our patented dynamic device key generation, or DDKG, technology that uses device hardware attributes to establish a trust anchor with devices. And the second is our PKI Signature Plus method that leverages standard asymmetric keys to authenticate. Okay, so I mean, there's a kind of a laundry list of features here for KeyScaler, and a lot of them are obviously parallel to our traditional on-premise deployments. We haven't cut anything out. It's still the same feature set, right, Ralph? We got the the flexible registration and secure device provisioning, including things like geofencing.
Right. So that's important thing here is to note down here, as Jim's mentioned, that the two different authentication methods would allow you to connect any type of device. We can leverage a root key from the manufacturing with the PKI Signature Plus protocol, or it could be our trust anchor post manufacturing. So the registration controls is very flexible with all kinds of features that we added. It's very important in an open platform cross-domain scenario.
Yeah.
The different products out there, right? The other important thing here is the connecting the dots, as Jim mentioned, the service connector architecture, the connectors to public CA vendors and the IoT platforms. For example, here, a automated certificate delivery to AWS IoT device. And with AWS IoT connector, we're able to automatically, create the thing and connect the device, deliver the certificate to the AWS IoT core. All that is automated. And same is, from a data point of view. That's from a device authentication. When it comes to IoT use cases, it's all about data. But when it comes end-to-end data security, all the way from creation to consumption, at rest in motion, right? So we have a service connector to ThingWorx platform. So with that, we can authenticate the device, extend the device authentication to ThingWorx. One. Second thing is, encrypt the data at the device and deliver that encrypted data to any entity within ThingWorx or the end user. That's very important in all the IoT use cases, right? So we have some patented good technology. At the same time, we promote all the standards-based device trust and data trust. So that's where PKI comes in a big way. The other key feature here is the automated password management. That's very unique for this platform. It's kind of can protect you from any kind of Mirai and other flavors, because based on our DDKG technology based, and there's no real anything stored at the device. It can provide secure soft storage, and it's more about recipe, not a real value stored anywhere on the device. That provides the very unique automated password management. These are all the laundry list of features, but important to note here is the architecture we have, the service connector architecture here, and then extending the trust, leveraging our partners, and then extending the trust to the IoT platforms in the cloud. And with IoT, the platform connectors, we automated. Coming down to trust and automation, those are the key for IoT security.
Excellent, well said. So we're going to run through a few examples here of just some of the things that KeyScaler as a service can really help you achieve with your kind of IoT projects. So in this first one, we're just going to talk about how KeyScaler as a service can help you automate the certificate provisioning and management process, not just for devices, but also provisioning those certificates to the IoT core service provided by AWS. So in this diagram, so this is again, sort of an architecture or solution flow for how KeyScaler as a service delivers those certificate provisioning for IoT devices and AWS IoT. The diagram really shows the full end-to-end process. I'm not going to depend on all of these, but you can see everything from the initial secure registration and key generation through to the CSR or certificate signing request submission to KeyScaler, and then KeyScaler using those service connectors to reach out and get the certificate signed by the appropriate certificate authority or subordinate CA. And then finally, once that certificate is signed and back in our hands, we can deliver that to the AWS IoT service using that service connector. And upon uploading it, either map the new certificate to an existing thing that exists in that AWS IoT service, or we can go in and automatically create a new record or new thing for that device. So once the certificate is delivered back down to the device, it can then be used to authenticate to AWS IoT using the standard mutual TLS mechanism that they support. And importantly, the solution can be consumed either using our out-of-the-box credential management agent, which is something we'll go into a little bit more detail about how to set up, or you could take our development libraries and APIs and integrate this into an existing application or a new application for kind of a closer relationship between KeyScaler and that device.
Yeah, and then one thing clearly, device-bound capabilities are very important and unique, and that's what is required for IoT use cases, actually. Yeah, and that's kind of missing in the IoT world today. In traditional IT world, they're dealt in isolation. Authentication and data security or even the device-bound, tying the authentication to the actual physical device.
Yeah, that's a good point, Ron. So we'll kind of take a look at the steps here that you'd kind of typically run through to set this up in KeyScaler as a service. So the first thing we have to do is create a service connector for AWS IoT service to tell KeyScaler where to deliver certificates once they've been issued. So from this menu, we choose the AWS IoT as the service provider, and you can punch in your standard AWS API key and API secret, and select the appropriate region from the drop-down box that you want to deliver the certs to. So once the service connector is configured, we can create the certificate management policy that controls how certificates are generated, signed, and delivered. Here we enable the AWS IoT auto provisioning option that you can see near the top, and select our newly configured AWS service connector and associated security policy. And then also select what kind of attribute of the device we want to use to map to existing things or create new things in that service. Scrolling down a little bit on that same page, we set a validity period for the certificates, enable auto rotation. So that really means that KeyScaler is going to manage that rotation event, once that certificate comes up for expiring. And if we enable that, we get the option to kind of choose how early we want to rotate that device certificate. And in this example, we're just setting the rotation window to 30 days. And that means the certificate rotation process will be invoked up to 30 days before the expiry. We can also choose where we want the key pair to be generated. So we can either generate it on the device or in KeyScaler, and choose whether we want to store the private key encrypted on the device, back to the secure soft storage that Raul mentioned earlier, and the device-bound capabilities. And just lastly, there's also some auto revocation options that can be enabled to make sure that KeyScaler will automatically revoke the certificate, both with the CA and with AWS IoT, should the device become quarantined or blacklisted or compromised. Okay, so now that the policy has been set up, we need to create a registration control record to whitelist our device. We can do this in a number of ways. In the screenshot, simply using the control panel that I mentioned earlier to create an individual record. Obviously not great for scale, but great for individual devices. We also have the option to bulk provision by importing a CSV file of device information. So you can list out, hundreds of thousands of devices in a CSV file and import it straight through the control panel. Another option is also to automate this process using the Device Authority Engine API. You can see here, I'm just going to create a simple record, locking down the registration using the MAC address and the operating system. We could use other attributes such as the IP address. There's options here for custom key value pairs, or we could use the latitude and longitude values to enforce that geofencing that we mentioned earlier. But once the record's been created, we then save it and we can start the credential management agent on the device that we provide. Typically that would be started on boot, and it will take care of the registration and key generation and encryption and key storage process. So once the agent has started up, we can see that the device is registered and that the certificate status has updated to delivered, which really gives you the visibility of the current status of that device and its associated certificates. And that means that the certificate has been delivered to both AWS IoT and the device. And if we take a look at the AWS IoT interface, we can see that a new thing has been automatically created for us, where one didn't exist before. And we can see that the new certificate that we issued as per the policy that we configured in KeyScaler as a service has been uploaded and attached to that new thing record. Okay. So in this example, just moving on, we'll talk about end-to-end crypto and how that relates specifically to the ThingWorx platform. In this architecture overview, we can see how the key derivation and authorization process is managed by KeyScaler as a service, shown here at the top of the diagram, and integrated with the ThingWorx platform. So on the left-hand side, we have the IoT devices that are obviously managed by KeyScaler. This can be in the form of our transparent crypto agent, which provides out-of-the-box crypto capabilities that typically don't require any changes to existing applications. And we do, by the way, have an agent that supports crypto for the ThingWorx proprietary always-on protocol, for those of you that are familiar with that. Or if you don't want to use an agent, obviously the same crypto can be integrated into an existing application just using our libraries and APIs. So as the data passes through the crypto agent on the device, it's checked and against the policies configured in KeyScaler, and then it's either encrypted or left to pass through untouched, depending on which properties we'll be targeting. Once the data lands in ThingWorx, we can use our crypto extension, a device authority's crypto extension, to decrypt the data, provided there is a decryption policy configured in KeyScaler that authorizes the ThingWorx instance to perform that action. So how would we set it up, right? So the first thing we need to do is set up an encryption policy for our devices. You can see here that we're targeting the ThingWorx always-on protocol. So this policy will only apply to messages that are sent over that particular protocol. We're also targeting specific properties with particular names. So as the data on the device passes through that crypto agent, they will be analyzed and evaluated against these policies and the properties defined within. So that means we can really split out the sensitive data from the not so sensitive and just protect what we need to keep private. So now that our crypto policy is in place and we're ready to encrypt some data, we can obviously start our applications on the device, start the device authority agent. The next step, really, once that information arrives in ThingWorx, is we need to actually authorize the ThingWorx platform to be able to decrypt the data. So we need to create a decryption policy. And it really has, the decryption policy has two purposes. The first is really to tell managed devices and applications what they should or shouldn't be even trying to decrypt. And the second purpose really is to authorize a given device or service to decrypt those specific data streams. So it's all of the authorization controls happen by linking these policies with their corresponding encryption policies. So that means that what we're effectively doing here is establishing permissions for the ThingWorx platform or any other devices that you want to grant access to decrypt data coming from our specific IoT devices. So you have that full protection of that data stream all the way from the device through any other existing hops in the flow, all the way back to ThingWorx, where it can be stored in the database and decrypted when necessary. So this is a screenshot. I just wanted to show off, part of the ThingWorx platform. And this particular screenshot that you're looking at here is our services that are provided by the device authority crypto extension. They're pretty simple, but they're also very powerful. For example, you can see highlighted here the encrypt and decrypt services, as well as the file-based crypto services for transforming data written to the file system. So, I mean, a lot of the interaction happens between KeyScaler and ThingWorx, and the policies obviously are enforced server side, and all the keys are kept separate. So that really allows you to adhere to security best practices by keeping those crypto keys away from and off the same box as the encrypted sensitive data. There's no need to manage or input any keys yourself. You can simply install that extension, point it to KeyScaler as a service, and we'll take care of the rest. And obviously spent a lot of time creating this this UI to show off the encrypted and decrypted values. This is a mashup, and that's what ThingWorx call their UI creations or creation tools. And on the left-hand side, I mean, it's a pretty simplistic diagram, but on the left-hand side, you can see the data as it was sent by the device and how it looked when it actually arrived at ThingWorx and was subsequently stored in the database. And we can leave it encrypted in the database and decrypt it on command, or we could simply decrypt it as it flows into the ThingWorx platform, you know, using that same crypto extension.
So James, you know, as you're explaining it, I can clearly see my medical device use case we talked about. You know, an oxygen concentrator can encrypt the field level, whatever the sensitive data you would like to encrypt.
Yep.
And that is sent all the way to a clinician if required, through the ThingWorx platform, and authorized parties can decrypt it.
That's correct.
End to end, right?
Yep.
The field level encryption delivered to the right party and associated with the device. It's device bound authentication and data crypto delivered end to end, right?
Correct.
And all these capabilities are available through APIs.
That is correct.
Fantastic.
Okay, so just one last example, and you know, I haven't got a bunch of screenshots for this. It's just a simple diagram, but so one last diagram to show, and this one highlights how KeyScaler as a service can be used to help you automate the secure provisioning of unique authentication tokens to your IoT devices. So they can be used to connect to the Microsoft Azure IoT Hub service. Yeah, so really what we're showing here is how KeyScaler can be used to provision and manage those shared access signature tokens for device authentication to the Azure IoT Hub service. So Microsoft have this concept of shared access signatures, and they're a way to authenticate devices to the various services without compromising secret keys or relying on hard-coded or even stored credentials on the device. So as you can see, the devices can connect to KeyScaler as a service to request the SaaS token first before communicating with Azure IoT. So this really helps you provide a secure out-of-band method for generating and transmitting these tokens to the devices. And it really helps when you think about the scale and automation required to manage the sheer volume of SaaS tokens for all these different IoT devices. This is a super simple way of creating one application that can get tokens on demand that allow it to connect to the Azure service. And in this scenario, we're actually the device is utilizing the Delegated Security Management WebSocket API to communicate with KeyScaler. We're very proud of that. It's a prompt-driven API that really focuses on simplicity, meaning that the IoT device and the developers building those applications simply connect to a single KeyScaler endpoint and is subsequently prompted for all the security operations in the order in which they need to be processed. For example, if the device isn't registered yet, KeyScaler will ask it to register. If it's already registered, it'll prompt it to go through the authentication steps.
This is a very important capability. Now, just showing SaaS token delivery to the device as an example here. The whole delivery mechanism, right? The delegated security management, not only just the tokens here, but you could be doing a lot of other functionality without having that implemented in your IoT application, right? Yep. So it's a very out of the band, I think, kind of a tokenized model that we are somewhat familiar with in the cloud IAM world, right? You're bringing all these KeyScaler functionality delivered to these applications and devices very elegant way.
Yeah, and it's a really good way to combine things like certificate delivery and management with the token provisioning, because you get to walk through those steps. And obviously, anytime a device wants to come back and connect to Azure, it has to come back to KeyScaler, wherein we can check the validity of its current certificate and issue it a new one if it's coming up to expire.
Right. With the service connectors, we can actually bring in our partner capabilities for trust and for data security or other means, or we can even interface to other data security platforms for key exchanges. So, I mean, this is highly scalable and very easy to implement, brings a lot of automation required for the IoT use cases.
Right. Okay, so focus on the partners. So one of the core features that we wanted to ensure is possible with KeyScaler as a service is the ability for our partners to offer this with as much flexibility as possible. So at a basic level, partners offering KeyScaler as a service to their customers can self-service to our hosted control panel. And this means that the partners can log into their own tenant, customize the logo and some of the branding, and really create new tenants for their customers without needing to contact us at the device authority. So it's fully self-service. The tenant management also offers license controls, so partners can manage the licenses that their customers have paid for. You can control the license number of devices, the license expiry, restrict certain functionality, and even offer temporary evaluation licenses for trials or POCs. Those tenant and licensing functions are also available through a set of APIs. And the APIs allow partners to integrate KeyScaler as a service into their own customer onboarding processes, or tuck it directly into an existing customer portal to offer the functionality, again, through that kind of single pane of glass experience. So in addition to the tenant management APIs, we also offer a whole suite of other APIs that allow our partners to provide visibility to their customers through their own user interface. We offer device management APIs to control the devices already registered in the system, enroll new devices, and we also have all the policy management APIs to create and deploy data crypto or certificate and password management policies.
Great. Yeah, it's making this platform available for customers, very easy for automation, for our partners to deliver as if all the features are available to native to their platforms for value-added services.
Absolutely.
Right. So kind of summary of what we've been saying. Thanks, James, a lot of good details about the under the hood KeyScaler platform. Clearly, the way you architected the engine, and again, the service access controller will be the front end, a good layer of security, and modular architecture with all these things. So this platform, KeyScaler, it's top left, as you can see, the first device-centric IoT IAM. It's a security management platform with the key features around automated PKI, automated security operations, especially the delegated security management model. It has been offered as on-prem solution so far. Now we have the SaaS offering. It's a proven platform. We have shown a lot of examples. All the platform vendors and partners there. To our main thing is about any enterprise class IoT use cases, that open platforms and cross domains. Automation is a key across multi-vendor products. So we focused on continuously growing the partnerships with Better Together story, with integrations as service connector architecture, as you can see at the bottom, especially the trust partners, Jamal Tatalis, public safety vendors, Digital Komodo, platform vendors, AWS IoT, Azure IoT, Hub, PTC ThingWorx, a lot of good use cases, especially in the healthcare and industrial IoT. So we're able to accomplish this differentiation with core patented technology, of course, proven ecosystem, a lot of early traction, the critical use cases in the healthcare industrial IoT. So our efforts are very well recognized for this platform. At the top analysts and see on the right side, we received a good coverage for innovation by SC Media on the top, on the bottom left or bottom right there. Anything else you want to say, James, about summary? Yeah.
No, I think you captured the good points.
Yeah. So with all that, clearly the benefits are obvious. Envision IoT benefits, compelling economic and social benefits. Security has been a big impediment for this adoption. So by bringing in the trust and automation with this platform, we can clearly talk about accelerating the IoT adoption for customers and partners delivering services. And again, a lot of the use cases that require compliance, especially as you know, it's all about data. This is one platform that actually uniquely combines the device trust and data trust. There isn't any other alternative for it. And people talk about device authentication in isolation. People talk about data security in isolation. But as I mentioned, device-bound data security is important for data compliance side, right? And automation is there's no better way of saying it. Looking at the IoT scale in billions of devices, provisioning and managing these devices at scale, delivering the device and data trust. And we didn't touch upon a few other things today, which is where we've been working with the manufacturing ecosystem as well. How do we leverage that trust from manufacturing? How do you onboard those devices without much of human intervention? So that's very important for operational efficiency. With this, we are able to demonstrate to our customers and partners, the revenue opportunities and customer satisfaction. We would like to enable more and more of our partners to deliver the value-added services, with our KeyScaler platform. So, in conclusion, as I mentioned, it's the first device-centric IoT IAM in the cloud. First one. We have seen the cloud IAMs in the past, but the first IoT IAM in the cloud. And James mentioned flexible authentication methods to support any type of device, the service connector architecture for open platform automation, end-to-end data security, delegated security management and APIs for easy integration with our partners' products. James, any more comments on this?
No, really. I think we hit the main points. I'm obviously very proud of the whole team for working on getting this deployed, and really excited to offer KeyScaler as a service to get people up and running as quick as possible, and just helping make security less of a burden for them during the project design and deployment phase.
Yeah, so very exciting offering actually to us and to our partners with the SaaS model. Again, all the benefits of SaaS, no infrastructure costs, and all the updates happen. Again, no need to talk about the SaaS benefits. So
yeah, I think they're understood at this point.
So yeah. So that I'll pass it back to Rosa.
Thank you, Rao and James. Great content as always. And I'd just like to echo, obviously it is a really exciting time for Device Authority and our partners and our customers. So I'm just going to open up for the Q&A now. So if anyone else wants to submit any questions, now is your chance. I've had a question about the secure by design approach that obviously we've spoken about openly before, and we're supporting it. But how, I guess, Rao and James, how can KeyScaler as a service directly encourage or support a secure by design approach?
Yeah, and the original slides we showed in the IoT solution, there was a root keys at the time of manufacturing. Then that becomes very important. So far, IT security evolved as an afterthought, and that is a fundamental issue. We've been focusing more on the detect, respond world. But IoT security is too important to be treated as an afterthought. Secure by design from the beginning is what is required. We've seen the Mirai type of attacks a few years ago, and that's where the government, I've seen the UK government publishing their policies about secure by design. You cannot have these insecure devices, number one. Number two, and there has to be a mechanism to disclose the vulnerabilities in time, right? So all those things are coming in, because security IoT is about a lot of economic and social benefits, just not producing products and services around it, right? With that, the liability across is happening. You cannot have insecure devices getting in the market. It's a safety issue as well, right? So we've been working with our ecosystem and a lot of initiatives in that. You would have seen the announcements from Microsoft itself, the Azure Sphere recently, and Intel worked on their secure device onboard. There are multiple initiatives. It was there before in the smart devices world, like mobile world especially. Now that's coming to the actual IoT use cases, open platform use cases, multiple products, right? So Yeah, it's happening. We have been part of that. We didn't go into the details on that front. We've been working with partners like Intel, Microsoft in that area.
Great. And what about for organizations without security expertise? Can KSaaS and device authority help?
I mean, yeah, absolutely. If you don't need to run or operate the security infrastructure, we take care of obviously all of that for you. I mean, we touched on the SaaS benefits, but we take care of the back end service hosting and all the rest of it. And we have a lot of sample projects and sample code and libraries and we also offer those out of the box kind of turnkey agents, which to the best of our abilities means that you don't actually have to understand or know the security, to be honest. You can just install one of these agents alongside the application on the device or just at the first gateway hop and encrypt your data as it passes through. Or for the I guess the certificate management or the token management, you've obviously got the credential management agent, which can automatically manage those certificates, and you can again use out of the box libraries to leverage that certificate to connect with the likes of AWS IoT, and automated password management as well, again tucked into that credential management agent. So it's packaged it up and try to make it as easy as possible for organizations to consume, and I think KeyScaler again is another step in that direction.
Now, I'd like to make one more point on that, James, because a lot of times security is tough, especially when it comes to the edge.
Yeah.
A lot of the vendors talk about security, but they provide you lots of source code modules.
Yeah.
And it's the customers. Then you need to have right expertise to take those modules, integrate with your application. It's like developer oriented.
It's trying to put together a puzzle.
Yeah, exactly. So
yeah.
I mean, nobody is taking responsibility of security, right? So here, what we have shown you in the screenshots, it's a configuration. We are a solution centric, a configurable option. We take care of all the burden of creating the connectors and assuring our customers and partners that these work. We just simply go through the configuration and solution centric. So it's very easy compared to other alternatives that customers have. So we're not developer centric that much, like the way others have, especially when it comes to edge trust, connecting that edge trust all the way to the applications, to the end users. We have done this effectively for all the medical devices use cases and this industrial IoT. Right there, we didn't talk to the developer. Actually, the solutions architect can actually simply configure and make it happen. Yeah,
that's a good point, Rob.
Okay, I've got one more question that's just come in. Can your technology provide data integrity? Example, ensuring that data has not been tampered, changed?
Yeah, absolutely. I mean, again, there's a number of different ways to do that. And the best route for that, obviously, and as it always appears to be, really depends on the use case. But yeah, absolutely. I mean, and it's an important part to try and tackle. Data, even though it's in its encrypted state, can still be modified sometimes in transit, which can create either still create an intelligent answer that wasn't actually the original answer in the first place. So data integrity is very much an important part of any solution. And yeah, absolutely. It's things like signing and HMAC signatures and things like that, which I won't get into here. But as part of what we do, we try to make that as easy as possible to consume and ensure that anyone using the platform gets the right solution for them.
One thing to add that is that we've been working with our partners. Data integrity is very crucial, especially when it comes to secure updates, right? We have the ability working with our partners to code sign, application signing, that to the device side, same way we can bring in signing capabilities on the device side to the application platforms. So clearly data security, privacy, integrity are very part of our trust. Yeah.
Great, thanks James and Rao. That concludes the Q&A session. Any unanswered questions will be followed up over the next couple of days. We've now actually come to the end of the webinar, so I just want to say another big thank you to Rao and James and also to our audience. And just a reminder that we're actually currently planning our autumn and winter webinar series, which is due to kick off in September. So please keep an eye out and we'll be sure to communicate it. If you have any further questions, please feel free to contact myself, Rao, or James. And in the meantime, thank you and goodbye.
Thank you.
Thank you all.